Well, welcome everyone. Yeah, thank you very much for joining. Yeah, my name's Nick, and I've got Ruby, my colleague, with me as well. We'll introduce ourselves, and we're going to give a talk to you for the next half an hour about the sort of latest research that we've been carrying out at HSE on respiratory protective devices. I've caught in the title there, respiratory protective devices are often sort of transferable to respiratory protective equipment. It just depends on the sort of exact sort of technical area that you're in, that they both mean the same sort of thing. Um, yeah, so my name's Nick Baxter. I wear a number of different hats. Yeah, I'm work for the Health and Safety Executive in their Science Division, and I'm their RPE technical lead. I'm also so we do a lot of research based on RPE, which inputs to all HC's guidance and policy and all that type of thing. I'm the chair of the British Standards Committee for Respiratory Protection, that's PH4. And as part of that work, I get involved with a lot of European and international standards committees, sort of developing performance standards, test method standards, sort of the selection and use, all to do with respiratory protection. I'm part of the British Safety Industry Federation Fit to Fit Technical Committee. So that's all about demonstrating the competence of fit testing that's carried out across the UK, and it's also spread into other countries in Europe as well. And then currently I'm the Vice President of the International Society for Respiratory Protection. So yeah, that's myself. And then quickly, Ruby.
Yeah, hi everyone. I tried to follow Nick's hat theme, but this is the only picture of myself with a hat that I have at my disposal. Yeah, I've been at HSE for about 2.5 years now, working with Nick as an RPE scientist. And before that, I did my undergrad at the University of Bath in biochemistry, and then drifted into the sort of microbial immunology sphere. And I did my master's and my PhD at the University of Birmingham, where I worked on immune responses to vaccines against invasive salmonella infections.
Thanks, Ruby. So yeah, just to kick off, I'm just a bit of a shameless plug for the ISRP Society that I'm vice president of. So it's all run by volunteers, and the main sort of aim objective of the society is to improve the better use of RPE and education of how sort of respiratory protection is across all different countries across the world, particularly the areas that don't have necessarily all the right sort of guidance and policies in place to help with that. So yeah, we sort of encourage participation in the development of standards. There's a journal where lots of people can publish sort of research and information on the better sort of development of RPE. We hold regular sort of seminars similar to this. We have a biannual conference. Last year it was in Oxford in the UK. Next year it's going to be in Canada. And one of the current sort of things that we're running at the moment is called the Face Up Project, and that's helping to try and improve and promote the better use of RPE for children, particularly sort of when to be used in places where there's lots of sort of air pollution and things like that. So yeah, if you're interested in any of that, then please have a look on the ISRP website or reach out to me and to ask any questions. The first thing I'm going to kick off is fit testing. And that's just basically to try and set the scene. And I'm sure we're all aware of fit testing, or hopefully anyway. And yeah, it just sort of gives us sort of an underpinning information, background information to help with what Ruby's going to talk to. So there's a number of different fit testing methods that are available. The first one is the qualitative method. It's often referred to as the taste test. It's very simple, very easy to carry out. And effectively, what you do is you put something over a bag over your head, or a hood over your head. You wear the mask. You spray inside the hood a bitter tasting or sweet tasting aerosol. Do some exercises, head movements, and essentially, if you can't taste the bitter or sweet tasting aerosol, then the mask fits you, and then it seems to have passed, and that's all good. It's subjective, so it relies on the wearer sort of responding and sort of indicating to the operator that they can taste the aerosol. and yeah, it's widely carried out and an effective method. The next two are quantitative methods. The first one is called the ambient particle counting method. So that uses a particle counting device. It measures the particles inside the room. It measures the particles inside the mask, works out that ratio to make a fit factor, and essentially the lower the number of particles inside the mask, the better the mask fits. There's a series of exercises to do, sort of stepping exercises to try and increase the heart rate, the breathing rate, a number of sort of head movements, talking exercises, all to try and replicate what you would do in the workplace, to try and stress the fit of that mask in the best it can. There's a control negative pressure method that's similar in terms of it's a quantitative, but it uses a pressure monitoring device. So it creates a negative pressure inside the mask and measures any leakage through that seal. Again, we sort of do some exercises to try and stress the fit of the mask. We sometimes don it off, don it on again. And again, that's measuring the fit of that mask sort of quantitatively. There's HSE guidance on the fit testing methods. That's in INDG 479. So that's on the left. There's a link to that there. And then that's also related to the British Safety Industry Federation, the Fit to Fit companion guides. So the HSE guidance is all about what you need to do in terms of complying with the law and all the requirements that you need to follow. And then the companion guides are all the useful information about how you need to achieve that and how you can do that and all the sort of top tips and those types of things. And again, there's the link to that there. So that's sort of generally about fit testing. Something else that we've developed recently is what we call a FRED video. Some of you may have seen FRED before, and if you haven't, it stands for Filtering Facepiece Respirator Demonstrator Tool. And that's a really good visual demonstration of how well RPE can work when it's fitted correctly. But the important part of that demonstration tool is that it also visually shows you what happens when the RPE doesn't fit you properly. So if you can see from the picture there, there's a head with a mask on. We fill the chamber with some smoke, and then the cylinder on the bottom represents the wearer's lungs, and we can breathe in and out, and that shows you what goes inside the lungs. If in that case there on the screen, the mask hasn't fitted them properly, and you can see that all the smoke goes inside the lungs. So instead of just sort of people standing up there in like toolbox talks or health and safety awareness days, anything like that, instead of just standing up and telling people all the information, we've got a visual demonstration to do that. And what we did in conjunction with BSIF, we developed a video. It's like 10 minutes long, and it gives you all the information about FRED and wearing RPE properly and fit testing and all sorts of different really useful things. So again, there's a link there to follow that. So I'll now hand over to Ruby, and Ruby's going to talk to us about some of the research that we've done on ear loop respirators. Over to you, Ruby.
Thanks, Nick. Yeah, just before I start, just want to acknowledge a few of our colleagues who contributed to this work, that I'm in the fortunate position where I get to present it. So next slide, please, Nick. So as we all know, COVID-19 drove a rapid and unprecedented increase in filtering facepiece respirators, which I'll refer to as FFPs throughout this presentation. So alongside the surge in sort of legitimate products and PPE and RPE, there were also a huge increase in ear loop designs on the market. And many of these carried inconsistent or incorrect markings to, related to CE, EN149, N95 and KN95. And this design before the pandemic was extremely uncommon in the UK market. So this was something that needed investigating a bit more thoroughly. Next slide, please, Nick. So within the media, there was a lot of visibility regarding FFPs, other ear loop respirators, and this was both good and bad visibility. Getting ahead of yourself there, Nick. there was a lot of confusion as well between face coverings and medical masks and RPE as well. And unfortunately, some of the bad habits that we saw in the media also transferred to workplaces where people expected the sort of protection of tight fitting RPE to be provided by these new types of respirators. Next slide, please. Internationally, a few different groups, including teams in the US and France, the Philippines, South Africa, and Iran, consistently showed poor fit test performance of these ear loop designs. The thing is, HSE sought UK specific guidance or evidence to support our COVID-19 guidance. So that led to the creation of these two separate research projects, looking at both non-certified ear loop respirators and certified ear loop respirators. Next slide, please. So the method that was used to look at, in the first instance, we looked at the non-certified respirators with ear loop straps. So we first got ethical approval from the University of Sheffield. We have an ethics committee who we work with closely in HSE. And then we recruited 29 volunteers to the study. So these 29 volunteers, they were all of Western European origin, and there were a spread of clean-shaven males and then females that we used. We used 8 different respirators with this ear loop strap design. All of these respirators had been quarantined from the UK PPE stockpile and were readily available on the market from autumn 2020. None of these respirators had certification documents to accompany them, and they all had varied markings like the ones I mentioned before, sort of CE, EN149, and they were all a vertical fold design like the ones you can see in the pictures on the right here. Next slide, please. So we used one of the quantitative fit testing methods that Nick mentioned earlier for our protocol. So the one that we used specifically was the ambient particle counting method. For this, we used the TSI port count with N95 technology enabled, and we worked to a pass-fail criteria of 100. The protocol specifically that we tested to was the one outlined in INDG 479. This is HSE's guidance on respiratory protective equipment fit testing. And we also used competent fit testers. Now, by this, we mean that all of our fit testers used in this study had a current and valid fit-to-fit accreditation. So they've been through a written exam and a practical exam and demonstrated their capability of performing a fit test properly. To reduce bias, we randomized the order in which the respirators were worn by the volunteers. So of the 8 respirators that we used, they were all worn in a different order. So we didn't have people like learning how to put a mask on better, for example. And our fit testers also gave instructions and guidance to achieve the best fit possible. So that the fit factors that we got out of these respirators were sort of a best case scenario. Next slide, please, Nick. So across this study of the non-certified ear loop respirators, we carried out 232 fit tests, and of these 232, only one of them achieved a fit factor above 100, which was a fit factor of 198. Overall, the geometric mean across all of the tests conducted was 3.8, and this was a 95% confidence interval between 3 and 4.7. So it's statistically and obviously significantly lower than the pass-fail of 100. Yeah, next slide, please, Nick. We also captured comments from the volunteers that we used in the study, both pre and post fit test. And 58% of the volunteers noted issues with these ear loop straps. So we had common comments of there was a lot of movement on the face during the fit test. There's a lot of leakage around the nose area, which also contributed to the fogging up of glasses. Anyone who's worn any sort of RP that doesn't fit properly, or even just the medical mask that fit properly and wears glasses, know that that's a telltale sign that you're just getting air blowing up through your nose. And the ear loop straps were said to be uncomfortable, and this was visibly noticeable, as again you can see in these pictures on the right hand side here. So there was nothing across both the quantitative data that we gathered and these comments that suggested that a good or reliable fit was achievable with these ear loop respirators. Next slide, please, Nick. So to move on to our second study, here we looked at certified respirators with ear loop straps. So the method was very similar to our original study. We again got ethical approval from the University of Sheffield. And this time we used 10 volunteers, and this was an even split of 5 clean-shaven males and 5 females, again of Western European origin. We used 9 respirators with ear loop straps this time, all again had the vertical fold design, but the difference between this and the last study was that these all had been certified to EN 149 by legitimate notified bodies. Additionally, in these, we had 4 respirators that had these so-called ear loop adjusters. These were a range of different like gadgets, I suppose I could say, that range from this sort of, you can see some images on the right hand side here, these plastic straps that you could hook the ear loop straps into, or some hooks, or these sort of little grommets that you could attach onto the ear loops, and it would improve the tension or increase the tension of the ear loop straps. We made sure to use them in our research, but we were unsure if these ear loop adjusters were used in the certification testing. Next slide, please, Nick. So again, protocol was very similar to the first study. We used a quantitative fit testing method, the ambient particle counting with the TSI porter count and N95 technology enabled. And again, that pass-fail criteria of 100. We followed the protocol as outlined in INDG 479, and again, we used fit-to-fit accredited fit testers, randomised the order of the respirators worn, and again, gave instruction and guidance to try and achieve the best fit possible. Next slide, please, Nick. So the figure on the left here, so these are the results of that second study. These show the geometric mean of each of the respirators for all 10 of the volunteers. So the bars show the geometric mean and the error bars show the 95% confidence interval. So across 90 fit tests, only 2 of them passed with fit factors of 133 and 201. And the overall geometric mean for all of these respirators was 5.2 with a confidence interval between 3.1 and 8.5. Again, significantly below that pass criteria of 100. When we specifically looked at the respirators with the ear loop adjusters, 3 of these products had slightly higher scores, but they all still failed to reach this 100 pass criteria. So the adjusters just weren't addressing the fundamental issue that we were seeing with these respirators, which the ear loops were not able to generate enough tension to create a consistent and tight-fitting seal. And if you look at these images on the right-hand side here, with Fred is making another appearance on these slides, you can see sort of, well, you can see down into the mask, there is daylight between the mask seal, and that was with fiddling for a good 10 or 15 minutes trying to get this mask to fit onto Fred. Not very well. So yeah, fundamental issues with trying to achieve a really good fit with these respirators. Next slide, please, Nick. So again, we got comments from our volunteers before and after the fit test, and they mirrored the comments that we'd received in the non-certified study. So again, there was movement on the face during the fit test. There was noticeable air leakage, glasses seemed to steamed up, and the general perceptions were that the respirator didn't fit correctly and there wasn't a good seal being achieved with this respirator. So even when the ear loop adjusters were used, for example, people struggled to achieve or even maintain a good seal. Next slide, please, Nick. So these findings directly informed HSE's regulatory actions. So in June 2020, so this was still, in the midst of the first wave of the pandemic, HSE issued a safety alert that focused on the non-certified ear loop respirators. They were to be removed from supply immediately, their effectiveness couldn't be assured, and they were unlikely to provide the required protection and meet essential health and safety requirements. So if certification was claimed on these respirators, it was on the suppliers to verify the authenticity and compliance. In April 2022, there was a general safety notice that more broadly addressed both certified and non-certified ear loop respirators. The conclusion was clear that the respirators with ear loop straps didn't provide adequate protection against respiratory hazards, and the statement specifically was HSE recommends that ear loops, masks, or respirators are not used as respiratory protective equipment in the workplace. It couldn't be assured that protection would be provided to workers, and therefore there was a risk of exposure to respiratory hazards. If you're interested in reading this, reading the safety notice specifically, you can scan this QR code on the right-hand side and it will take you to HSE's website and their safety notice. So that brings me to the end of my section. I might have just rattled through that very quickly, so apologies, Nick. But yeah, I'll hand back over to Nick now, who will continue to talk about ISO protection levels.
Yeah, nice one. Thank you, Ruby. Yeah, so it's a really good example of the sort of work that we do and research that we do that impacts onto what HSE's policy and guidance does. So yeah, it's a really good example. So thank you, Ruby. What I'm going to talk about next is not specifically something that we've done research in at the moment. It's something that we are really interested in and we're involved with, and we want to continue with that and do future research. It is something that's called the ISO protection level. So currently, for different types of respiratory protection, so the ISO protection level is a new system that's been introduced by the International Standards Organization in terms of how RPE is used and selected. So at the moment, we have a wide range of different types of RPD, ranging from simple filtering face pieces all the way through half masks, full face masks, and you've got powered, and then airline and breathing apparatus types of things, and that's across the whole globe. So in different countries, there's all these different types of RPD. That's what we currently have at the moment. Across the world, across the globe, there's lots of different standards associated with all these different types of RPD, and they're all different for very similar types of products. So you've got in Europe, there's a standard for filtering face pieces. In America, there's a similar standard for their types of filtering face pieces. And same with all the other different types of RPD. So what we're looking at is trying to look at the sort of variation that we have at the moment under the sort of current system that we use for RPD. And that goes across for China, Canada, Australia, all the different types of all the different countries and all the different types of RPD that's currently used. And within a specific type of RPD, there is a standard associated with that. And I've taken one here, EN 12942, as an example. So that's a European standard for powered filtering RPD with a tight fitting full face mask, for example. And within that particular standard, there's lots of different products from different manufacturers that are all certified to that standard, and some of them are better than others. So in that standard, there's requirements, lots of requirements, for example, breathing resistance, and you could have an RPD from one manufacturer that has got a much better, much lower breathing resistance, better for the wearer than another product. And same for things like inward leakage, there's mechanical strength, noise levels, a whole range of different things. And then there's no real way of just sort of distinguishing between a product that's really good and another product that is just over the pass-fail criteria. All that happens is that they get certified, they've passed all the requirements, and then they can then be sold onto the market as they're all effective of RPD. And all the different types of RPE that we use, RPD that we use across the world, in Europe and in the UK, they all have what's called an assigned protection factor. And that just dictates how much protection that type of RPD has and provides to the wearer. And the assigned protection factors across different countries are all different, and the definition of an assigned protection factor also varies slightly. They're all generally the same. And what I've given here is my own interpretation and a simplified version of what an assigned protection factor is. What that is it's the level of protection provided by the RPD when it is worn in an effective RPD program. And there's a cycle there on the right-hand side that sort of dictates what an RPD program should look like. And we're starting off with an adequate risk assessment is carried out to identify the hazards. That then leads on to selecting the right type of RPD for the hazard and for the protection that's needed. It then needs to be used correctly. The wearers need to be trained. Everyone that's associated with using the RPE needs to be trained on it and its effective use. Once it's been used, it needs to be cleaned, maintained, stored, all these types of things. And if that's done correctly and to a certain level of degree, then that is good. And then the RPD provides the wearer with the protection that is needed. And as I mentioned, the assigned protection factors vary from country to country and from different types of RPE. And so for half mast, for example, there's a wide range. For powered filtering pieces, you can go from low as 5, assigned protection from 5 all the way up to 500, depending on what country it's used in. And that's for the same type of RPD. And the assigned protection factors are all derived from workplace protection factor studies. So that's studies that have gone out into the workplace, measured the protection of the RPD, and it's been used to work out how much protection it should provide to the wearer across the whole country. To give you a visual sort of representation of what an APF is so if you've got a wearer with a mask on, if they're exposed to a hazard, a dust hazard, for example, if that exposure is 20, the particular exposure limit could be 5, for example. If the assigned protection factor of the RPE was 10, that reduces the exposure by a factor of 10. And in this instance, if the exposure was 20, reduce it by a factor of 10, the exposure to the wearer would be reduced to 2. Which would be below the exposure limit, which is good. That's what we want to happen. So that's in very general terms what an assigned protection factor looks like. As I mentioned, the assigned protection factors in the UK across all the different countries are all derived by workplace protection factor studies. These were carried out many years ago on a wide range of different types of RPD across many different industries. And all the different countries sort of chose their assigned protection factors for the different types of RPD, depending on their own requirements, the regulations that they have in place, the effective use of RPE and the hierarchy of control, and they sort of chose them accordingly. But in terms of the workplace protection factor studies that were carried out, unfortunately, they weren't carried out consistently. So there's lots of variations in how the samples were taken, whether training was provided to the RPD wearers, whether they were fit tested or not, the sort of competency of that fit testing, what types of industries they were carried out in, what working exercises they were doing. So there's lots of things that are variable with all that data. And this contributed to all the different sort of assigned protection factors that we have for the different types of RPD. And just to link that to the sort of hierarchy of control, just to sort of, we're all aware of this, and obviously RPE, PPE comes at the very bottom. We've sort of talked about all the sort of variations in how RPE can be used, the assigned protection factors associated with those. There's also different sort of variations in the different control methods that are put in place, the sort of national regulations around all those controls. So there's lots of variability in how RPE can be, exposure to the wearer can be controlled, and what we're specifically looking at is in relation to RPE. So just try to summarise that. Obviously, it's probably a little bit sort of difficult, but I've talked about the fact that there's lots of different types of RPD devices, different products. There's a range of different standards associated with those different types of RPE from country to country. Within one specific type of standard, you can find variations in the performance of those products. There is variation depending on the workplace studies that were carried out to establish those assigned protection factors. RPD programs, it sort of dictates how well RPD is used in the workplace. Again, there's sort of industries, employers that do that really, really well. There's industries, employers that don't do as well. Lots of different variations in how the systems are operated. And in some cases, some of the assigned protection factors, there wasn't any data or perhaps wasn't enough data to establish those assigned protection factors. So in that case, some expert judgment was used as well. But generally, what we see and what is generally considered by ourselves, technical experts, by yourselves, sort of consultants, all the way down to the end user, is that we typically understand that as we progress from filtering face pieces through to half mask, full face mask, all the way up to breathing apparatus, the protection and the assigned protection factor increases. And that's widely understood. But what has been developed over the last sort of 20 years, and it's been a sort of long time in the making, is to try and bring all the different variabilities together in terms of the performance of the different products, the standard requirements, and to have one international standard for the performance of respiratory protective devices. And that's what's been worked on by the international standards committees. They've developed one performance standard, which is ISO 17420, and that encompasses every type of RPD. There's a number of different sort of parts associated with that. As you can imagine, that document is very, very big. There's sort of special applications for different types of products, for fire and rescue, for CBRN applications and that type of thing. But that essentially is one standard for any type of RPD for the performance requirements. Associated with that performance standard is a series of test method standards. So that is ISO 16900. So there's a number of different test method standards for breathing resistance, for inward leakage, for all the types of tests that are needed. So again, the performance requirements are standardized, the test methods are standardized, and then there's also a series ISO 16975, which is all about how RPE should be used, selected, and maintained, and used correctly in an effective RPD program. So that's trying to bring everything together for everybody to use across the globe. And within that system, the standards committees at the time recognised that there was variations in the assigned protection factors, as I've discussed previously, and they came up with a new system called a protection class and a protection level, an ISO protection level, which is a new way of a new indicator of the in-use performance of RPD in the workplace. And that came up with 6 protection classes. The lowest one is protection class 1, all the way up to the highest, which is protection class of 6. And that has got an associated protection level, which is the level of protection offered by the RPD. So, for example, protection class 3, an RPD with a protection class 3 would have a protection level of 30. So that would reduce the exposure to the wearer by a factor of 30. The main difference with the ISO system is that instead of using workplace data, this new system uses laboratory-based total inward leakage testing. So that's measuring the leakage into the RPD measured in the laboratory. One of the good things about that is that it's done in a laboratory test. It's standardized in terms of the method that is used, the equipment, the expertise, and essentially we're wanting the same test to be done every time. That is done as part of the certification test by the sort of certified test laboratories. It's done obviously in controlled laboratory conditions. There's a series of different simulated working activities like walking, sort of bending, head movements. There's a whole range of different activities that could be selected. Essentially, each RPD should be assessed to fit the wearer correctly. And also one part of the testing is that the RPD is assessed on a range of facial sizes. So a certain manufacturer can produce an RPD that fits a small size population, or a medium size or a large size, depending on what they want to do. So it's based on laboratory tests and it's not based on workplace data. One of the main differences with the ISO protection level system is that essentially any type of RPD can have any protection level. So what I've done here on the screen is that this isn't based on any data or anything. This is just purely my personal perspective of what potentially could happen in this new system. So, for example, filtering face pieces, as we know now, would generally be on the lower end of the protection level. So you talk, yeah, the 4, 10, 30, which is typically what we see now. Half mask, I would imagine, will be roughly in the middle. So you're going to get a general level of protection around the sort of 30, 200 mark, that type of thing. And then the typically higher level of performing RPD, so full face masks, powered equipment, airline breathing apparatus are going to be much, much higher. But the key thing here is that you potentially could have, for example, a half mask from one manufacturer that has got a protection level of 30, for example. The next manufacturer could have a protection level of 250. So for within the same type of RPD, a half mask from two different manufacturers could have different protection levels, which is not what we see at the moment. Another interesting aspect to this is that potentially you could have, for example, a half mask that has a higher level of protection than a full face mask. And again, that's not something that we're typically used to seeing. So like I said, that's not based on any data. That's just essentially under the ISO protection level system, any type of RPD could have any level of protection in theory. And that's a typical sort of spread of what potentially could happen. When will this be implemented, the ISO protection level system and the ISO RPD performance standards? So I mentioned they've been in development for quite a number of years now. They've been published already. So in 2021, all these standards, or majority of them, were published. And the main question is when and will different countries adopt these? So within Europe, we haven't adopted them yet. There's been many conversations over sort of quite a few years ago, and recently I'm trying to sort of re-engage those conversations to try and establish whether they will be adopted or not. In the past, in the European committees, we've considered a 6-year transition period, but again, nothing like that has been agreed or set. So at the moment, there is no date within Europe to adopt these. Interestingly, in Australia, they have started an implementation of the ISO standards. At the moment, they have a sort of implementation date of 2030. So it seems like a long way away, but they're currently at the moment going through significant discussions, consultations with experts throughout the globe to try and understand exactly how they're going to implement this, because it's such a huge change in how RPE is used and selected. And they're looking at different things in terms of restricting what ISO protection levels for different types of products are, whether they need to reduce the actual performance levels of them. And really how that they're going to transfer that information and guidance to the end user and how it's going to be used. So people like myself, I'm taking a real keen interest from a technical perspective, also from a perspective of sort of input into HSE's policy, and also all the European sort of countries are taking a real watchful eye on what Australia are doing and how they're going to sort of go through this process. The important thing to note, though, is that this new ISO protection level system, there has been no validation data for that. It hasn't been validated. The ISO committees at the time acknowledged that there was no validation data available, and they sort of took a decision that they needed to get the standards published so that research institutes, manufacturers, etc., would be able to start carrying out validation data, well, with the hope that they would carry out validation data to try and improve and promote the adoption of these standards. But unfortunately, that hasn't happened. So as my role as ISRP within the International Society for Respiratory Protection, I'm trying to sort of again re-engage that conversation and try and promote the national sort of regulators, different research institutes, different manufacturers to try and start some validation of that data. And that's something that we're wanting to do as HSE as well. Yeah, at the moment, that's certainly not been implemented. If it would be implemented within Europe, it is a number of years away. But yeah, it's just something to try and highlight that new system is out there. Yeah, so that's the end of the presentation. Yeah, and sign back to you, Lee. Any questions or anything what you want to do?
Yeah, thank you very much for both the presentations there. I see that there has been a couple of messages dropped into the chat, and I think, Ruby, you've been busy typing away there, answering some of them. I don't know, have you found any questions that you think would be worth having a quick discussion on while you've been browsing? I don't know if, Nick, if you want to dive into the questions as well on the chat bubble. There is a hand up, actually, if you wanted to... Ahmad, if you wanted to come off mute and ask your question.
Yeah, hi. Good afternoon. How are you? Thank you. Thanks for the session. I have a quick one. Am I audible to you?
Yeah.
Yeah, we can hear you.
Yeah. I have a small, quick one. Actually, for quantitative testing, any machine like the POTA count or OHD emissions, they have some specific values like 2500, 3000, some numbers. If the breathing rate matches with that number, then only the quantitative test is passed, or otherwise it will fail. So I just want to know how these values are designed, who designed.
In terms of the pass-fail criteria for the different types of RPE, is that what you're questioning?
Sorry, I didn't get.
Oh, sorry, yeah, I'm just trying to. I didn't quite hear your question. Are you asking how did the pass-fail criteria for different types of RPD were established for fit testing?
No, I'm sorry to interrupt. That is not my concern. There was a specific number like 500, 2500, some numbers. In total together, if you get the number, then only the quantitative test, the machine will give the pass result in POTA count machine, or it might be OHD. Why? Because I done so many fit tests for different kind of SCBAs, the manufacturers like Drager, MSEA, Scott. So there was a specific number. So I just want to know who will and which body is, which body is concerned for this kind of numbering system.
Yeah, so essentially sorry, go on.
I hope you understand this question. I'm sorry, maybe I didn't frame exactly. I don't know.
Yeah, so well, fit testing has been around for quite a long time. Excuse me, and yeah, within the UK, we're one of the sort of leading national regulations in terms of pushing forward fit testing. Excuse me. And yeah, all the numbers and the pass-fail criteria are all based on research that was carried out sort of 20, 30 years ago. There's quite a lot of information and research that was carried out on the sort of pass-fail criteria and how all the manufacturers of the control negative pressure method and the ambient particle mounting method, they all sort of put together and developed the research and their technology at the time. If that helps.
Okay, and one more, if you don't mind. These negative pressure mask, loose fit or ear loop straps, whether we can use for ODAR or like a 0.2 ppm H2S concerns, we can use them. Is it appropriate to use these kind of ear loop straps, mask?
Yeah, so HSE's recommendation is that ear loop filtering face pieces should not be used for respiratory protection.
Okay.
That's specifically just aimed at for the UK market.
Yeah. And regarding this APFs, which ISO standard is responsible for designing these APFs values, assigned protection values?
The assigned protection factor values. Apologies, I'm struggling to hear what your question was. Apologies.
Okay, I'm sorry. See, my concern is for protection class, protection level. In protection level, there are 4, 10, 30, 10,000. The numbers are there. These numbers are universal for everyone. So, which body is regulating them, or which body is concerned to this kind of standards?
Yeah, so the ISO protection levels were established by the ISO standards committee, which is it's called subcommittee 15, and the working groups and the technical experts established those. That's all based on sort of theory, and so yeah, essentially they've not been validated. So it's up to, if they were adopted by Europe, for example, then the national bodies and the national regulations within those countries would need to be confident that those levels were acceptable, as they're doing in Australia at the moment. They're sort of going through this process of trying to validate that and trying to fit that in with their current sort of regulations.
Thank you so much for your information.
Excellent.
But if you've got any specific questions, any other on that, if I've not answered those fully, then please get in touch with us and we can try and explain that a bit further.
Yeah, well, we've got quite a few questions. So I was going to say that if we don't get through all of them, maybe I will copy and paste all the questions we've had, send them over, and if you send over the answers in written form, I can upload those and have those on the BOHS website for kind of future resource. So we do have another question here. We got Lee Heffernan. Lee, if you want to come off mute and ask.
Hi Lee, thanks very much. Yeah, hi
No
Nick. Hi Ruby. Lee Heffernan from BP. Yeah, I don't know if you got a chance to read my question in the chat box, but what's the HSE's view on newer types of RPE that don't neatly fit into one of your existing RPE categories in HSG 53? So the example I've shared in the chat box there from Camlock, they've combined a traditional full face mask with a cowl, and it's aimed at workers with facial hair and beards. Yeah. They've done testing at the HSE lab in Buxton as well as in Eastern Europe, proving very high protection factors over 100,000, so well exceeding the 2,000. But because it doesn't neatly fit into an existing category in HSG 53, what is the HSE's view on us adopting this? So the energy companies do use it in the Middle East, in France, and Canada's given permission for it. Thank you.
Yeah, no, it's a really interesting product and really interesting question. And essentially, we in terms of HSE, we want to see a product fit in line with the requirements that are given in HSE 53. So, for example, a self-contained breathing apparatus needs to be tested and certified to EM 137. So in order for that to be tested against EM 137, it needs to be certified and tested with clean shaven people. We as HSE, our guidance says that tight fitting RPD should be worn by clean shaven wearers. And yeah, so within the UK, that's sort of our stance on that. I'm aware that the Camlock product, it's been used in sort of countries that you mentioned in the Middle East with people with beards, and that certain product it has not been tested and certified to EM 137. So that's where we sort of stand with that one.
Okay, but I mean, we allow non-tight fitting hoods with powered RPE, with facial hair, and without fit testing. So this is combining that technology, the non-tight fitting cowl, with the hood. So what would Camlock would you be the right person for Camlock to work with to see what extra testing they need to do, to satisfy the HSE?
Me specifically, or?
But yeah, as the RPE SME for HSE, would you be the right contact for them to work with on this?
Well, myself and in conjunction with HSE policy colleagues, then yeah, that's where we would need to have conversations about that. My role and Ruby's role and the team that we work in, we don't have any influence on HSE policy and HSE guidance. We provide the research and the technical guidance on to HSE policy colleagues, who then go ahead and go away and discuss and sort of formulate HSE's policy and sort of positions based on the information that we provide and the whole range of other information in terms of how RPE is used, input from other sort of associations and various other types of things. I'm more than happy to have conversations about that, yeah, but I would need to involve many others within HSE as well.
Okay, thanks. I'll pass on your details. Thank you.
Oh, thank you.
Excellent, thank you for that, Lee. So I don't know if you've had a chance to look at the chat there. I don't know if there are any questions that jump out. There's one that's been given 2 thumbs up towards the start. Christopher Hodson asked, we've started seeing these types of RPE on sites, and then there's a link below if you can just click into that. Have you had any experience with these types of masks, and do you recommend them? I don't know if you can see that. It's just near the top of the chat box. I think it's at the 3rd and 4th messages down.
I'll try and find it.
That one's just had a couple of thumbs up, so I just thought maybe that would be one worth discussing.
Is that the Swiss Air? The Swiss Air product?
That would be it, yeah, that's it.
What was the question again?
We started seeing these types of RPE on sites. Have you any experience with these types of masks, and do you recommend them? And that's another thumb up as well. So I think a few people want to know a little bit more about these if possible.
Yeah, so I'll bring my good old HSE card out, which we don't recommend any products. We can't sort of recommend one product over the other. This one is really interesting, and it's something that we have looked at, and it typically looks like a traditional tight-fitting half mask, but it's designed and certified as a loose-fitting device. So should be in the sort of the regulations and the guidance that we give and the standards that it's been approved to, should be used as a loose-fitting device. So yeah, that's essentially the information and the position that HSE has, and it should be used accordingly.
Excellent, thank you. And then just scrolling down a bit, there's a few more questions down at the bottom. I don't think Ruby got to, because she was typing away while you were talking there. So Cahill has asked, supplied air hoods in European countries such as Ireland have an APF of up to 1,000 based on third-party research. In UK, these hoods have an APF of 40. Is there going to be any research by HSE if these hoods provide greater protection than powered air purifying respirators?
Yeah, that is the one of the variations in the sign protection factors. Is there is a huge difference between one country and another, particularly between the UK and other countries in Europe. At the moment, HSE has no we have no plans to alter or adopt any of the sign protection factors that we have. In one aspect, that is really good for the end user and the protection that it offers the end user is because we are very conservative, and because the sign protection factors are much lower, that puts more emphasis on the other control methods that for things like LEVs and stuff like that. Obviously, we all know that RPE is the last line of defence. So if something goes wrong with the RPE, then it fails to danger. So in that aspect, it's better for the UK wearer. I'm not saying that it's not better for any in the other countries, but it provides a much robust system.
Excellent, thank you. We've got a couple of minutes, so I'll try and rifle through as many as we can before we get to 3 o'clock. So Sarah has asked, will the manufacturers of respiratory protection be assigning their own PC number based on their testing, since they can vary?
Yeah, so the idea is that it's not the manufacturer that assigns the protection class or the protection level. Then they would send their product for certification as they would do now, and it would be tested by the notified body and the test laboratory. And depending on the result of that certification testing, well, in particular the total and leakage test, depending on the result of that test, then it would be assigned the appropriate protection class and protection level. I would have thought that the manufacturer would have an idea of what protection class and protection level it would come out at, given that they would be carrying out their own internal research, market research. Then, yeah, they would have an idea of what that would be in the first place.
And then I think we've probably got time for one last one. Sorry if I've skipped over your question. Like I say, I'll compile all the questions and we'll get a proper Q&A based off the back of this webinar and distribute that hopefully in the next week or so. So maybe the last question will be from Ian here. With PLs being more closely aligned to an NPF, do you expect there to be an APL if these standards are implemented to take account for real world use?
Yeah, that is a really good question. Yeah, there's lots more work to be done on that topic. Particularly initially, there needs to be validation data for the laboratory testing that could be carried out, and then that also needs to be, as they've suggested, how that relates to actual real world protection. At the moment, it's generally sort of conceived that when you do a test in a laboratory, you get much higher protection than when it's used in the workplace. How that sort of relationship, the ratio between laboratory testing in the ISO protection level world and the real world, that's yet to be sort of formulated or decided, or there's been very little research into that. So that's definitely something that is a question that needs answering.
Okay, well, like I say, that'll probably be the last question for the Q&A now. But like I say, if it's okay, compile the questions, send them over, and we'll release it as a document, a nice little Q&A or an FAQ off the back of all of the questions that's been asked. Apologies again if we didn't get around to your question, but thank you to everyone who has submitted one. I'm sure it'll make for very handy reading whenever we've put together a document off the back of it. This has been recorded, so if you have missed anything or want to revisit it, if you check on the BOHS YouTube channel, hopefully in the next couple of hours, it should be up there for you to share, to revisit, to share with colleagues who couldn't attend the webinar, etc. So with that, thank you to Nick, thank you to Ruby for your presentations today. And I think that's everything, if there's no final words from yourselves.
No, that's great. Thank you very much for having us. Yeah, it's been really enjoyable.
Excellent, spot on. Well, enjoy the rest of your afternoon and hopefully your sunny weekends, and we'll see you in the next BOHS webinar.